Hello everyone, this is Mr. Ahmed Faidi from Manard Al Farouk Language School, Math Department, and today, inshallah, I will help you to review your lesson.
Our lesson today, Unit 2, Lesson 9, Application of Similarity in the Circle, Part 2. Today we'll talk about converse of the well-known problem. If the two lines containing the two segments AB and CD intersect at a point E, and we have A, B, C, D, and E are distinct points, and EA times EB equals EC times ED, then the points A, B, C, and D lie on a circle. So if we have EA times EB equals EC times ED, then A, B, C, and D lie on a circle. And from converse of well-known problem, we can write the ratio EA over EC equals ED over EB. Then, do you think that the two triangles AED and triangle CEB are similar? Of course, we have the ratio EA over EC and equal ED over EB, and we have measure of angle E the same in the two triangle. In the first case, VOA, and in second case, we have angle E is a common angle. So the two triangle will be similar. If EA over EC equal ED over EB, then triangle EAD similar to triangle ECB. Corollary number 2, if you have EA square equals EB times EC, EA square equals EB times EC, then EA is a tangent segment to the circle which passes through the points A and B and C. Okay, example number 1. In which of the following figures the points A, B, C, and D lie on the circle? Then explain your answer. We have EA 5 centimeter and EB 20 centimeter. So we will multiply EA by EB and we find EC times ED. If they are equal, then A, B, C, and D lies on a circle. So since AB intersects CD at the point E and EA times EB 5 by 20 equals 100, this is number 1. And since EC times ED equals 10 times 10 equals 100 also, this is number 2. So from 1 and 2, EA times EB equals EC times ED, and this is converse of well-known problem. So the points A, B, C, and D lie on, since AB intersects CD at the point E, and since EB times EA, 3 by EA, which is 9 plus 3 is 12, so 3 by 12 will be 36. This is number 1. So I will find ED times EC. ED, which is 4 centimeter, and EC 5 plus 4, which is 9. So ED times EC 4 by 9 will be 36. And this is number 2. From 1 and 2, we have EA or EB times EA equals ED times EC. Then the points A, B, C, and D lie on a circle. Example C, we have the two lines AB and CD intersect at the point E. Then we will find EC multiply by ED, or we can say ED times EC. EC, which is 4.4 plus 2.8, which is 7.2, multiply ED, which is 2.8, will be 20.16. And this is number 1. Then I will find EA times EB. EA, which is 3.6 plus 2.4, which is 6 centimeter, and EB, which is 3.6. EA times EB, 6 multiplied 3.6 will be 21.6. From 102, we find that EC times ED not equal EA times EB. Therefore, A, B, C, and D not lie on a circle.
Another example in which of the following figures is AB is a tangent segment to the circle which passes through the points B, C, and D. If we want to find if AB is a tangent or not, so we will find AB square. So first I find AB square, which is 6 over 2 equals 36, and this is number 1. Then I will find from AC times AD. AC equals 4 centimeter. AD equals 4 plus 5, 9 centimeter. So AC times AD, 4 times 9 equals 36. And this is number 2. From 102, we find AB square equals AC times AD. Then AB is a tangent segment to the circle which passes through the points B, C, and D. Another example is AB is a tangent, so I will find AB square. So AB square equals 9 to the power of 2, which is 81. Then I will find from AC times AD. AC, which is 6, and AD 6 plus 7, which is 13 centimeter. So 6 by 13 will be 78. And this is number 2. From 102, we will find that AB square not equal AC times AD. Then AB is not a tangent segment to the circle which passes through the points B, C, and D. Another example, we have AB 6 centimeter and BC 8 centimeter, and we have CD 6.4. So if I want to find AD, I will find AD first. In triangle ABC, we have angle B 90 degree. Then AC, which is the hypotenuse, equal square root 6 power 2 plus 8 power 2 will be 10 centimeter. So AC 10 centimeter, and we have part from AC, CD, which is CD 6.4, so AD will be 3.6. So we will find AB square 6 power 2, which is 36, and this is number 1. Then I will find from AD times AC. AD 3.6 times AC, which is 10, which is equal 36, and this is number 2. We have AB square equal 36. AD times AC equals 36. So AB square equals AD times AC. So AB is a tangent segment to the circle which passes through the points B, C, and D. Another example, in each of the following figures, A, B, C, D lie on a circle, explain your answer. So I will find EA times EB, which is 6 by 7, which is 42. So since AB intersects CD at the point E, then I will find EA times EB, 6 times 7, 42. This is number 1. And I will find EC times ED, 5 times 8.4, will be also 42. From 1 and 2, we find EA times EB equals EC times ED. Then ABCD lie on a circle. Thank you for your listening and see you later.